Hello. This video includes information on balancing chemical equations.
We're going to start with just chemical reactions and how we can represent them with equations. So when we look at a chemical equation, we want to be able to recognize what the reactants are, what the products are, and the importance of coefficients in those equations. So when we talk about the reactants are on the left-hand side of the reaction. Okay, they're the things that react together. And the coefficient or the products are on the right-hand side. So in this case, we've got CH4 reacting with O2. So those are our reactants. And we're going to produce CO2 and H2O. Those are our products. And the coefficients are the way we're going to relate how these substances react together. So in this particular reaction, we have one molecule of CH4 for every 2 O2 to produce 1 CO2 and 2 H2O. So the coefficients give us the relative amount of reactants and products in a chemical reaction. Now, there's no coefficient that's written here, but it's assumed to be a 1. And there's no coefficient here, but it's assumed to be a 1. So what do these coefficients mean? So if we look at this reaction, it tells us that it's a 1 to 2 to 1 to 2 ratio. Okay, now, it could be a 2 to 4 to 2 to 4 or 3 to 6 to 3 to 6 ratio. When we write the coefficients in a balanced equation, we typically write them as the simplest ratio, but it can be any ratio. So if we were to look at this here, okay, same reaction. So we've got 1 CH4 reacting with 2 O2 and 1 CH4 reacting with 2 O2 and 1 CH4 reacting with 2 O2s. And we're going to produce for every 1, 2, 3 CH4 that reacts, we're going to produce 1, 2, 3 CO2 because they're a 1 to 1 ratio. For every 1, 2, 3, 4, 5, 6 O2 that reacts, we're going to produce 1, 2, 3, 4, 5, 6 H2O because they are a 2 to 2 or a 1 to 1 ratio. And for every 1, 2, 3 CH4 that react, we're going to produce 1, 2, 3, 4, 5, 6 H2O because it's a 1 to 2 ratio. So when we look at a balanced equation, it tells us the relative reactants and products for that particular reaction. So a 1 to 1 to 2 particle ratio, a 1 to 2 to 1 to 2 mole ratio. And again, one molecule for every 2 O2s yield 1 carbon dioxide for every 2 H2Os. They're ratios. Okay, so we need to deal with those coefficients. How do we figure out what they are? We're going to balance equations to figure out what those coefficients are. And we need to have equal numbers of atoms of each element on the reactant side and the product side of a balanced chemical equation. Okay, it's a law of conservation of mass. So if we were to look at, again, this as our representative reaction for now, we have 1 carbon per CH4, and there's one CH4. So there's one carbon on the reactant side. There's one carbon per carbon dioxide on the product side, and there's one carbon dioxide. So there's one carbon, one carbon. Okay, there's 4 hydrogens in each CH4, and there's one CH4. So there's 4 hydrogens on the reactant side. And there are 2 hydrogens per water, and there are 2 waters. So there's 4 hydrogens on the product side. And if we were to look at oxygen, there are 2 oxygens per diatomic molecule of oxygen, and there are 2 of them. So there are 4 oxygens on the reactant side. There are 2 oxygens in carbon dioxide, and there's 1 oxygen and 2 water molecules for our water. So that's 2 plus 2. There are 4 oxygens on the product side. So to have a balanced equation, we would have to put a 2 here in front of the oxygen and put a 2 here in front of the water. Now, an important thing is when we balance equations, the only thing we can adjust is what the coefficients are in front of all the formulas. We can't change what the formulas are themselves. Okay, so we couldn't make this a 2 and make it H2O2. That's not water anymore. Or H4O2, that's not water. But we can say we've got 2 waters. And we couldn't say O4 to balance out the oxygens because oxygen's diatomic, but we can say we have 2 of them. So when we balance equations, we can adjust the coefficients in front to get the atoms to be equal on both sides of the arrow in that reaction. We can't change what the equations are. So states. Okay, when we talk about chemical reactions, we want to identify whether the reactants and products are solids, liquids, or gases. Now, the first thing you want to do is use some common sense because a lot of them you know whether they're a solid, liquid, or a gas. Okay, but we've talked about this when we looked at the periodic table. Most elements on the periodic table are solids. Okay, hydrogen, nitrogen, oxygen, chlorine, fluorine, and the noble gases are all gases. Okay, it kind of makes a 7 in the upper right-hand side of the periodic table with the exception of hydrogen, which is a little unusual. We talked about how mercury and bromine are the only elements that are liquids at room temperature. Compounds that are in compounds are typically solids unless it's specified otherwise. Okay, and we're going to start looking at solubility rules in just a minute. Now, some things that we should just be aware of because we're going to use them pretty often. NH3 is ammonia, and ammonia is a gas. CH4 is methane, and methane's a gas. C2 or C6, H6 is called benzene. That's always a liquid. Any combination of nitrogen oxides are gases. Dry or C6H12O6, sugar, is a solid. Dry ice is a solid. Ice, liquid water is a solid. Steam is water as a gas. Okay, and we're going to see these often, so we should know, these states, we should know which elements on the periodic table are gases, which elements are liquids, the rest of them are solids, and most ionic compounds are solids unless it's specified otherwise. So let's look at balancing some problems. Okay, let's look at NH4NO3, so that's ammonium nitrate, producing dinitrogen monoxide and water. So we want to look at the nitrogens or hydrogens first. Okay, it doesn't really matter what order. So let's look at the hydrogens. Figure out how many hydrogens are on the reactant side and how many are on the product side. So we've got 4 hydrogens on the reactant side. And we've got 2 hydrogens on the product side. They're not equal. We can't change the subscripts, but we can put a coefficient in front of the water, which is a multiple. to balance out the hydrogen. So if we put a 2, that's going to give us 4 hydrogens on the reactant side and 4 hydrogens on the product side. All right. Now let's look at nitrogen. The trick here is that nitrogen is here and it's also here on the reactant side. That means we have 2 nitrogens on the reactant side and we've got nitrogen here. There are 2 nitrogens on the product side. Nitrogen's balanced. Now we want to look at oxygen. Okay, well, oxygen's here on the reactant side. There are 3 of them. And on the product side, it's in 2 places. We've got 1 here and we've got 2 here. That means we've got 3. So this equation is balanced with a 1, and a 2 as our coefficients. And again, the ones we're going to assume. I'm not going to write them. All right, so let's look at this one. We've got sulfur dioxide reacting with oxygen to produce sulfur trioxide. All right, let's start with oxygen. Figure out how many oxygens you have on the reactant side and how many oxygens you have on the product side. So we've got 2 here. We've got 2 here. That means we've got 4. We've got 3 here. All right, now this is what I would say to do. If you have an even number of an element on one side of the equation and you have an odd number on the other side, multiply the odd number by 2. When you multiply any odd number by 2, it becomes an even number. So at least now it's going to be a little bit easier for us to balance them because they're both even. Now, if we put a 2 in front of the sulfur dioxide, that's going to give us 6 oxygens on both sides. And it's going to give us 2 sulfurs on both sides. So now we have a balanced equation. So if you have an even number on one side and an odd number on the other side, multiply the odd number by 2, it'll make it much easier to balance the equation. Now, you do not have to show this work, and you do not have to show this work. I'm just showing it so that you can see where the numbers are coming from. Hopefully you will get to the point where balancing equations, you can kind of just go back and forth in your head and get them balanced. And a great thing about balancing equations is that once they're balanced, you know they're right. A frustrating thing might be if you try and balance it and it's not balanced. And if you get to that point and you can't get an equation to be balanced, I would erase it and start over again because you probably wrote a formula wrong. So let's try this one. We've got iron reacting with chlorine, and we're producing iron 3 chloride. Okay, so we're going to start with the chlorines. Figure out how many chlorines are on both sides. What you're going to want to do to get the chlorines to be balanced. And then what you'd need to do to balance the fluorine or the irons when you're done. So we've got 2 chlorines on the reactant side and 3 chlorines on the product side. They're not equal. Okay, if you've got an even number on one side and an odd number on the other side, multiply the odd number by 2. And then see if that helps to balance it. That's going to give you 6 on the product side for chlorine. That means you're going to have to multiply the reactant side by 3 to get 6 chlorines on the reactant side. And then when you look at iron, you've got 1 on the reactant side, but 2 on the product side. So you're going to have to multiply the iron on the reactant side by 2. All right, this one's a little bit harder. Give you a minute and see if you can balance this out. We've got nickel hydroxide reacting with nitric acid to produce nickel nitrate and water. So you need to get the nickel, the oxygen, and the hydrogen balanced on both sides of the equation. What might make this easier, and you can't always do this, but for this one, since there's a nitrate here and a nitrate here, you can balance them as a unit. Might make it a little bit easier than trying to do them separate. Now remember that hydrogen is in both the nickel hydroxide and the nitric acid. So there's 4 hydrogens on the reactant side, and you end up with 4 on the product side. So you should have a 1, a 2, a 1, and a 2 for your balanced equation. All right, let's look at this one. Now, lots of things in there. Look at this. Here's an acetate, C2H3O2. Here's an acetate, C2H3O2. So balance them as a unit. Here's a sulfate, SO4. Here's a sulfate, SO4. So balance those polyatomic ions as units as opposed to balancing the atoms. It'll make it just a little bit easier. Okay, so I'm getting a 2 to 3 to 1 to 6 ratio. All right, let's try this one. Okay, this is called the hydrocarbon. It's butane reacting with oxygen. We're producing carbon dioxide and water. Okay, so I'll give you a minute or so, see if you can balance it. So start with your carbons, see how many carbons are on the reactant side, how many carbons are on the product side, how are you going to balance it? Then look at I would do your hydrogen next. How many hydrogens are on the reactant side, how many hydrogens are on the product side? And then look at your oxygens and how are you going to get them balanced? And you don't necessarily have to show your work. If you can just, go back and forth in your head and balance it, that's great. All right, so let's see what we get. If we look at carbon, there are 4 carbons on the reactant side and there's 1 carbon on the product side. So to get carbon to be balanced, we're going to multiply the product side by 4. Now let's look at hydrogen. We have 10 hydrogens on the reactant side and we have 2 hydrogens on the product side. So if we multiply the product side by 5, that balances out the hydrogens. Here's where the problem comes in. If we look at oxygen, we have 2 oxygens on the reactant side. We have 2 oxygens here, but we have 5 oxygens here. Now, we're going to need, I don't like the way this is written, but we're going to need to multiply everything by 2. When we do that, that'll give us 2, 13, 8, 10. Okay, now why did we do that? Because we've got 13 oxygens on the product side. We need 13 oxygens on the reactant side. So we're going to have to multiply the carbon by 2, multiply the hydrogen by 2, and then the oxygens will be balanced. So 2 times 4, that gives us 8 carbons. 8 times 1, that gives us 8 carbons. Carbons are balanced. 2 times 10, that gives us 20 hydrogens. 10 times 2, that gives us 20 hydrogens. 13 times 2, that gives us 26 oxygens. 2 times 8, that gives us 16. Plus 10 times 1, that gives us 10. 16 times 10 is 26. 26 and 26 is equal.